Good day, ladies and gentlemen. Maths 101. This is Michael and my partner Alfred. Today, we're going to talk about three topics of calculus. The first one is basic differentiation, and then we have further differentiation, and for the last one, indefinite integration.
So our first problem here presents us with a diagram. It is also stated that in the diagram, it shows the part of the curve y is equal to bracket x minus 1 to the power of negative 2 plus 2, and the line x is equal to 1 and equal to 3. The point A on the curve has coordinate 2, 3, and the normal to the curve at A crosses the line x equal 1 at B. So here, we are asked to show that the equation of the normal AB is equal to y equals 1 by 2x plus 2. So we're going to add another variable, which is u, and since our given equation is y is equal to x minus 1 to the power of negative 2 plus 2, we will substitute x minus 1 with our new variable, which is the letter u. Therefore, we can rewrite our equation as y equals u to the power of negative 2 plus 2. Now, to find the derivatives, we must multiply the derived function of y with the derived function of u, and we call it du. And because our u is x minus 1, our du will simply be 1, because the derivatives of a constant is 0, and we neglect minus 1 since we deduct 1 from the integers. We will end up with x to the power 0, which is equal to 1. So lucky for us here in this equation, we can neglect du since it's simply a positive 1. Therefore, we need to find the derivative of y itself, which is minus 2u to the power of minus 3. We are expected to obtain this result from the general formula of differentiation. Afterwards, we are supposed to plug in the values of u, which gives us the derivative of y as minus 2 bracket x minus 1 to the power of negative 3. And for our next step, we are expected to find the gradient when x is equal to 2. And since we know that dy dx is equal to gradient, thus we plug in our x value to the derived function of y, giving us the result of minus 2 bracket 2 minus 1 to the power negative 3, which gives us the value of gradient as m equals negative 2. And we know that the normal line equation is y minus y1 is equal to m1 bracket x minus x1, and the value of m1 is equal to negative 1 by m. So therefore our m1 would be 1 by 2. Then we combine all the acquired values in the given equation of the normal line, where our y is equal to 3 and our x is equal to 2, proving that the normal line y minus 3 equals 1 by 2 bracket x minus 2 is equal to the given equation, which is y equals 1 by 2x plus 2. Let us move on to our second question. It is given that the curve is such that dy dx is equal to x to the power of 3 minus 4 by x to the power 2, with the point P, which has the coordinate of 2, 9, lies on the curve. First, we are asked to find the rate of change of y coordinate when the point is at P, given that a point moves on the curve in such a way that the x coordinate is decreasing at a constant rate of 0.05 units per second. Since we were asked to find the rate of change in the y coordinate over time, we can write this as dy dt. And one way to obtain dy dt is by multiplying dy dx with dx dt. Now we are given that dy dx is equal to x cubed minus 4 by x squared. Given that our x value at the point P is 2, we can plug it in, giving us dy dx as 7, whereas dx dt is explicitly stated in the question that is 0.05 units per second. But since it is decreasing, we are going to consider it as negative. Therefore, we multiply 7 with negative 0.05, giving us dy dt is equal to negative 0.35. For the second part of the question, we're asked to find the equation of the curve. We can find this using integrals. So we're going to find the integral of x cubed minus 4 by x squared using the general formula of integrals, which is x to the power n plus 1 divided by n plus 1 plus c. So we plug in each individual values to our general formula. So for example, like x cubed, we're going to add its integer by 1 and divide it with the integer plus 1 as well. So since the power is 3, we're going to add 1 to it, making it x to the power 4. But since we're going to divide it with its own integer plus 1, which is 3 plus 1, it becomes 1 by 4x. The same rule applies to negative 4x to the power of negative 2, giving us the result of 1 by 4x to the power 4 minus 4 by negative 1 x to the power negative 1. Therefore, our equation is y is equal to x to the power 4 by 4 plus 4 by x plus c. And then we're going to plug in the value of x and y in order for us to find c. And it was given that x is equal to 2 and y was equal to 9. Therefore, our equation would be 9 is equal to 16 by 4 plus 2 plus c, resulting to c equals 3. So the equation of this curve would be y is equal to x to the power 4 by 4 plus 4 by x plus 3. And that's our final answer.